Hello my peeps, this Algebra Nation video will cover workbook page 108, problem square root 64.
To this stuff. Alright, so this stuff is 4 square root 6, and that's multiplied by 3 square root 15. We're multiplying those two together. Now again, look at your answer choices. What do I see? I see that I only have one square root and one number outside in all of my answer choices. So that's what I'm going for. Alright, well, how do I put all that together, huh? Well, when I'm multiplying here, I can only multiply the numbers on the outside together, and I can only multiply the numbers under the square roots together. Think of it this way. If I have 3x times 4x, when I combine these together, I'll do 3 times 3, which will give me 12. And then I do x times x, which will give me x squared. All right, so same thing here. I'm going to do 4 times 3 on the outside, and then underneath the square root, when I have two square roots like this, square root of 6 times square root of 15, the way I'm going to combine those together is I can actually put them all under the same square root. That's just how it works. So that's the rule that I'm going to use here. All right, so I have 4 times 3 gives me 12. And I'll do square root of 6 times 15. So 6 times 15, grab your calculator or just be a nerd like me and do it in your head. That'll give you that it's the square root of 90. So I've got 12 square root 90. All right, well, I can look over here at my answer choices. I don't see 12 square root of 90. Uh-oh. What do I see? I see 12 square root of 80. Well, that can't be it. Can't be 12 square root of 10 either. And there's no way for it to get small enough to be D. So you could actually take a guess here that it's A. But let's go ahead and show why it is A. All right, let's say maybe this isn't a multiple choice question. Let's go ahead and work through this. So we have square root of 90 underneath. Now, in order to simplify this, remember we could take out any perfect squares, right? So perfect squares, you just sort of want to have this list in your head. We have 4, 9, and then I blanked out. 4, 9, 16, 20, 25. If you're good with those, that's probably a good list. And just remember that these are all some number squared. So 4 is 2 squared, 9 is 3 squared, 16 is 4 squared, 25 is 5 squared. All right, so I definitely had that list down. When I took this class, I know I had those at least at the ready. So that's a good list to have memorized. All right, so right here I see I have 90. Can I factor out one of these? I see I got a 9, right? So I could pull that out. And as long as you pull one out, even if you're left with another perfect square in there, you can pull out one that's too small. So for example, let me give an example of what I'm trying to say here. Let's say that I had 162. Kind of a big one. That might not be one that we need to do, but 162. I could start off and I could say, 162. Well, it's an even number, so maybe I can divide it by 4. Nope, can't do that. All right, well, go to the next one on my list, 9. Can I divide 162 by 9? Whoops. 162 divided by 9. Oh, sweet, that gave me 18. So I can break this up into 9 and 18. And then when I factor 9, I can factor 9 into 3 and 3. Oh, but I can pull out another perfect square from 18, right? So that's actually going to be 9 times 2. So I pick up another 9 here, and then that's going to come out as well. So again, you can start with a number that's too small. You'll just have to keep simplifying, keep pulling out perfect squares. All right. Now, in this problem, we're actually good to just go ahead and pull out 9. We're going to go ahead and factor this to 9 times 10. So square root of 9 times 10. And then now that we have this square here, we can go ahead and evaluate the square root on just the 9, and that's going to give us, well, the square root of 9 is 3, right? We have listed here. So we'll do 12 times 3. Got to pull that 3 to the outside. And we still have square root of 10 left over on the inside. And then finally, we have 12 times 3. Just go ahead and multiply them together. Give us 36 square root of 10. And boom, just like I had guessed earlier, it is in fact A, 36 square root of 10. So the reason, by the way, that I said it couldn't get smaller, 12 square root of 90 could never become 7 square root of 21. Why is that? Well, we already have a number on the outside that's bigger than that one, and the number on the inside is bigger than 21, so that just wouldn't even make sense. And these other ones, we see we had 12 times the square root of some other number, so you could automatically knock those out. All right, so if you have any other questions on this, feel free to post them on the